everyone. So I wanted to make a quick video demonstrating how to do some of these calculations that you will find in the WAVES lab / the Fort Funston lab. So the first calculation that I want us to do is determining the wave classification with a given water depth and a given wavelength. So you'll see in the lab that there is a table that gives both of those values, and what I want you to do is run through this relationship to see if any of them are true. And I want you to run through all three scenarios, even if, say, you're doing the deep water relation first and you find that hey, it's a deep water wave, still go through and double check to see if it's an intermediate or a shallow water wave as well. Okay, so this is kind of how I would do it. So I will kind of just write the relationship down. So deep is H is greater than 1/2 of the depth, which is lambda D. So I like kind of writing it down up there. So in this example that I'm going to just kind of flail numbers out the top of my head. So say the water depth is 30 meters. So I'll just kind of off to the side here, I'm going to say H is equal to 30. And then I'll say that the wavelength is equal to, which is lambda, that's that weird little like upside down Y thing. So then I'll say the wavelength in deep water is like, I don't know, 60 for, okay. So now I have that kind of written off to the side here. And by the way, you can do this on a whiteboard and then just take pictures of it and then record that, or take pictures of that. That is totally fine with me. So to walk through this first relationship, let's see if 30 is greater than 1/2 of, and it might actually be greater than or equal to. I think it's supposed to have that equals to there as well, but here we are. Greater than or equal to 60. So I've literally wrote it out step by step, but I'm going to put a little question mark there just to be like, is it true though? So is 30 greater than or equal to 1/2 of 60? Happens to also be 30. Is that true? Yes, it sure is. So this is actually a really good example. So being like, okay, the first relationship I went through, yes, that's true, but let's just for funsies go through each relationship just in case. So then for intermediate, let's say we want to double check if it's 1/2 of lambda. Is that less than the height? And is that, or excuse me, greater than the height, and is that greater than 1/20th of lambda? So I've written down my relationship. That's the relationship we're going to check. Okay, so then you plug your numbers in. So 1/2, oops, not 1/20th. 1/2 of lambda, that's 60. Is that greater than 30? And is that greater than 1/20th of 60? And so you don't need any fancy pants calculator here. You should just be able to use the calculator on your phone or on your computer. By the way, your computer does have a calculator. So 30, so I don't know off the top of my head, 60 divided by 20. So 60 divided by 20 is 3. So is that greater than 3? Question mark. So that's where I'm at now. So is 30 greater than 30 greater than 3? So far, yes, that's still indeed checks out, right? Right? Yeah. And now we have our shallow water wave. So we're trying to determine if this is also a shallow water wave. So relation for that is 1/20th of the depth. Is that greater than the height? Again, just writing that all down there. So then plugging our numbers in is 1/20th of 60 greater than 30? Question mark. Is that relationship true? So is 30 greater than 30? No, it is not. So that relationship does not work. So then if I had this in my table, then I would in the table say deep and intermediate. So maybe it's kind of starting to go into that transitionary period of being a shallow water wave. So that's just me throwing out numbers. And you may notice that the last little line there with the water depth of 5 and the wavelength of 100, maybe you'll find that that doesn't satisfy anything, and that's because I simply made those numbers up and completely forgot to change it in the lab before I posted it. So here we are. So that one might be a little funky. It's okay. It's because I just pulled numbers out of my head. Sometimes that works. In this instance, it kind of did. Sometimes it doesn't work. In this instance. So that's the first calculation. So I want you to go through all of those steps for each of those examples that I provided. And if you do not show your work fully, you will not get full credit. So please make sure you show your work. And if you need another example of that, please, 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 as I always say, reach out and let me know, and I'm happy to help you in any way that I can. Next, I have two other relations, and this is where we're going to be looking at the speed of water then, okay? So I have two relationships for us. One is a deep water relationship, so I'll just write this on down here, deep, which is the speed is equal to gravity times the wave period over 2 pi. And then the shallow speed is C is equal to the square root of gravity, or G times D, and the D is water depth. This is all spelled out in the lab part. So what I've done is I've said consider two waves, both of which have a specific period, and both of which, one is a deep water wave and one's a shallow water wave in a particular depth. So what I want you to do is once again do a calculation. So let's say I'm going to do an example where the period, or the T, is equal to, say, 25 seconds. See, again, I'm just pulling numbers out of my booty. So I'm saying T is 25, and my water depth, which is D, I'm going to say is 15 meters. Actually, I'm going to do 18 meters. That was the deepest I ever dove in when I got scuba dive certified. So we'll just go with that. So I want you to work through these equations. So this is what my setup looks like, right? So I wrote down my deep water relation, and I wrote down my shallow water relation, and I've wrote down also what I've given, what I'm making up numbers giving. So what I want you to do is simply step through these things, right? So I'll find my deep water speed. So C is equal to gravity, which I give us is 9.8. And it's always good here to write out your units. That way you're sure that you are canceling things out properly. 9.8, and then I'm giving us a period of 25 seconds divided by 2 times pi. This is how I've written this part out. So 9.8 meters per second squared times 25 seconds. So with this, our seconds are actually going to, 1 second is going to cancel out. So it's still going to be meters per second. It's awesome. It's a great unit of speed. So then that will be 9.8, goodness gracious, 9.8 times 25, which is equal to 245, still over 2 pi. And if you have an iPhone and you're like, I don't know like how to flip it. So if you turn your phone, or I think maybe even on a Google phone or whatever, on Android, if you go and make sure that you can flip things over, you can still go to your calculator, if it will work. Of course, it's not going to work when I try and show it. It always works that way. And you flip it over, then you have the full calculator. And there should be pi there. Maybe. Used to be. Or I think I said that you can use 3.14, which is fine. So 3.14 times 2, which is 6.28, meters per second. Okay, so I have 245 divided by 6.28. 245 divided by 6.28 is equal to, holy bananas, they're moving quite fast, 39, and it's 39.01, but we'll just say 39.0 meters per second. So that is the speed of my deep water wave. Then, off to the side here, I'll do it in green. I want to find the speed of the shallow water wave. So that is, so C would be equal to the square root of 9.8 meters per second squared, times 18 meters. So a big thing here, sorry, I know it's kind of off to the side there. Big thing here is you need to multiply those two numbers before you take the square root, okay? So that's a common thing that students miss, which is totally fine. It's a common, I mean, I would mess that up all the time as well. So 9.8 times 18 is 176.4, so that would be meters squared per second squared. So 176.4 meters squared per second squared, meters times meters is meters squared. And then you would take the square root of that. So if you're using your cell phone, you should, there's like a little, I know it's kind of hard to see with my crappy camera, but the little square root symbol with the 2 on the outside of the square root symbol, that is square root. And once you click that, then it automatically does it. So the square root of 176.4 is 13.3, we're going to round it up, 13.3 meters per second. Nup agrees. So that's how you would do that, 13.3 meters per second. Okay. If you need any help with that, please reach out to me. If you just leave those questions blank or you don't show your work, then you're not going to get credit for it. And I would rather help you understand what's going on than have you just be super lost and completely not get it. So there should be the two kind of main calculations. The other one is to calculate the wave period, which is after the Fort Funston thing. If you need help with that, just let me know. That's where you just take the average of the average waves that you got and then divide that. So if you need any help with anything, again, please let me know. I'm happy to assist you in any way that I can. Thank you so much.